right. Live lesson. Today is Wednesday the 13th. Wednesday the 13th. Ooh. All right. Today we're talking about functions and relations and the sort. A function is a relation where every input has exactly one output. In other words, x's can only be used once. Look at this room. X's can only be used once. So I'm going to give you either a picture or I'm going to give you a bunch of points. And if at any point you see the x's repeat, it is no longer a function. If the x's don't repeat, or if the domain, or if the input doesn't repeat, then you do have a function. Everything is good. So which of these are functions? Right away, right off the bat, this is not a function. Okay? If you're wondering why, well, there's an x value that does repeat. -2 goes to 1 and 3. So that's like saying if I have an arrow and I paint on that arrow -2 and I fire that arrow at a bunch of targets, that arrow magically splits from -2. It magically splits and hits 2 targets, one labeled 1 and one labeled 3. And this ain't Peter Pan. Wait, no. Robin Hood. This ain't Robin Hood. Oh, boy. Take a look at this guy right here. I have a bunch of students in my class like Nellie and Marcos and Esther. And I asked them how many family members age. I don't know. I guess I don't know what they're doing, but they're adding up all the age, whatever. But if I ask every student, they're not going to have 2 answers. So Nellie has her own answer, and Marcos has his own, and Esther has hers, and Sam has his, and Nina has hers, and Paul has his, and Hurricane Katrina has hers, and Andrew has his, and Marina has hers, and Anna has hers. Everybody has their own answer. So none of these x values repeat, which means this is a function. So this was not because the x values repeated. I didn't see any of those names in the input repeating, so it is a function. Okay, similar problems. Once again, the x values repeat here. So this is not a function. If you're like, what do you mean they don't repeat? 2. If I have an arrow and I paint 2 on it and I shoot that arrow at targets and it splits into 2 arrows and it hits 2 different targets, that's not possible. Okay. Now I took the information from the last thing and flipped them. And as you can see here, 47 and 13 are going to 2 different things. And in this case, this goes to 3 different things. This is also not a function. You're going to hear a lot of noise in the background. That's my children misbehaving. Stop playing the guitar, please. Lexi, can you please not play the guitar? Thanks, baby. Love you. Okay. Not a function. And not a function. So let's do a few more. Which are functions? Let me see. -3 is used once, -2, -1, 2, and 3. Those x values are used 1 time each, so that is a function. -3, -2, 1, and 1. Uh-oh. Pew-pew. Not a function because the x value is used twice. The x value 1 specifically is used twice. 100 goes to 15. I'm sorry, 10 goes to 15. 20 goes to its own number. 30 goes to its own number. 40 goes to its own number. We have a function here. Okay? So that's one way of determining whether things are functions or not. I either give you a mapping diagram, or I give you a chart, or I give you points. And from there, you can figure out, by the way, this is called a mapping diagram. From there, I can figure out whether it's a function or not. Another way that you can figure out if something is a function is called the vertical line test. If a vertical line passes through a graph more than once, it is not a function. Vertical line means up and down. Okay, vertical line means straight up and down line. So if I were to draw a vertical line here, it only hits the blue once. If I were to draw it here, it only hits the blue once. if I were to draw a bunch of vertical lines, it's only going to hit the blue once. What does that mean for this guy? Well, this guy right here is a function because I could draw as many vertical lines as I want, and it's only going to hit my blue line once. Similarly here, I could draw vertical lines everywhere, and it's only going to hit my blue line once. So this is also a function. However, this guy, if I draw a vertical line here, it hits my circle twice. And the moment it hits my graph more than once, it is not a function. Okay? Vertical line test. So if I take a vertical line and I draw a vertical line, hits the blue line once, hits the blue dot 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 once, it's the blue dot once. Function. Let's get a different color in here. So nothing, nothing, once, nothing, nothing. That's a function. And this picture is not that pretty. But as you can see, it hits the blue once, hits the blue once, hits the blue once. It's a steep drop. It only hits it once. All of these are functions. Good job, me. Good job coming up with possible answers. Okay. So again, going back to the previous page, those are ways that you could determine if something is a function or not. And this is a way of determining if something is a function or not. So let's look at a crazy one. If you see a circle that's filled in, that means that is part of the line. If you see a circle that's not filled in, it means it doesn't count as part of the line. So if I were to draw a vertical line here, see how I have this line here, it kind of bumps up and then bumps over with a circle and then blah, blah, blah. If I were to draw a line there, it only hits my line once. Here's where it gets tricky. If I draw that vertical line there, see how that circle is not filled in? That means it doesn't count. So it's literally like if I have a pothole, I could skip over it, it doesn't count, and it hits that filled in black dot once. So what this line is saying here is that my vertical line only goes through my line once. Same thing here. Hits the line, that doesn't count. So it only goes through it once. Only goes through it once. So is this a function? Yes, it is. So you'll run into tricky ones like that. But if it's not filled in, it doesn't count. All right. Now what? Linear. Look at the key word there. Well, maybe let's add another letter to it. Linear function looks like a line. If I graph a line, it is in the form y equals mx plus b. And if you're like, that's slope-intercept form, it sure is. Notice, though, the important thing here is x is just x. So they can't have x values like x squared or the square root of x or something over like 5 over x or x cubed. X has to be x. It doesn't matter what's attached to it. It doesn't matter what else is floating around. I could have a billion x minus a trillion square root jillion bajillion. If x has no attachments, okay, like if it has no exponents, if x doesn't have a square root, if x is on the top and not the bottom, it is a linear function. And if it's a linear function, that means it follows a pattern. Okay? So here we go. Which is linear? Well, it's y equals mx plus b. Let me take a look. I don't care about you. You don't matter. I don't care about you. You don't matter. Let me take a look at you. See how x is x? No squared, no square root of x, no x on the bottom, no negative exponents, no cubed, no exponents. X is x, which means this is linear. Is that not straight line linear? No, because it's not a straight line. There will be problems that'll be like, is that linear? Explain. And you'll be like, no, because it's not a line. Simple as that. So this guy right here, I don't have A picture, I don't have an equation. I just have a bunch of numbers. So I need to make sure they follow a pattern. What happens here? I add 1. What happens here? I add 1. What happens here? I add 1. So my pattern on the left is +1. On the right, what do I have? +3, +3, +3. So the left side has a pattern that doesn't repeat. That does repeat. It's all +1. The right side is +3. Since it follows a pattern on the left and on the right, it is linear. And there goes my guitar. It fell on the ground. Which are linear? Well, y equals blah, blah, blah. And notice it's red already. Red because it's bad. See how x has an x squared? The moment you take an x and attach an exponent or a square root or put it on the bottom, it is no longer linear. So this is non-linear. Is this guy right here linear? Is it a straight line? Yes. Then it's linear. What's going on here? +1, +1, +1. To get from 4 to 1, -3. To get from 1 to 0, -1. Uh-oh. See how that guy right there is different from the others? That means it's non-linear because it doesn't follow the same pattern. And if you're like, I don't understand why. If it's a straight line, every time it goes up a certain amount, it's going to go over the same amount, up and over, up and over, up and over, up and over. It's basically like steps. So if you were to design steps, it's got to follow the same pattern. If you were to design these steps, notice how this step is a whole lot bigger than the other two steps. Well, it's stopped following a pattern. It's like if you're going up 5 inches to take a step and over 5 inches, up 5 inches, and all of a sudden you have a step that's up 15 inches. It's not a perfect step anymore. All right. Write each function rule, use appropriate letters. If I ever see the word output, that means Y. If I ever see the word input, that means X. So when it says the output is, Y is always equals, half is 1/2, of means times, the input X. Y is half of X. Charlie, C for Charlie, is 3 years younger than John. Now let's do it wrong. You're going to want to be tempted to say 3 years younger than John. But that doesn't make sense because what if John's like 30? So if John's like 30, you're basically saying Charlie is negative 27 years old. Well, that can't be right. Here's a fun fact. If you're doing these problems and you see than, switch it. So put John over here. Younger still means minus. And put 3 over here. So Charlie is whatever John's age is, take away 3. So if John is 30, then Charlie is going to be 30 minus 3, 27. So if you don't know what to do, make up a problem in your own head and then solve it in your own head and be like, oh, okay. There you go. The output is 6 multiplied, bad job by me, to the sum. Yeah, this is a big typo. I don't know what I was doing here. Big typo. All right, next problem. All right, last page. This is where it gets iffy. Write each function rule, use appropriate letters. All right. Function rules are in the form of mx plus b. M is rise over run. In our case, I don't have a graph. The rise is the y values, and the run is the x values. So whatever I find my patterns to be, I'm going to find out the y over the x that way. So x goes up by 2, up by 2, up by 2. Run goes up by 6, up by 6, up by 6. If the slope is y over x, then the slope in this case is the y values, which is 6, positive 6, over the x values, which is positive 2. 6 divided by 2 is 3. Now, normally what we would do is we'd do lin reg, but I don't have a calculator on me, so I'm not doing lin reg. What I have so far is y equals 3x plus b. If you're wondering, well, what's b? B is the y-intercept. And the y-intercept exists when the x value is 0. Oh, look, the x value is 0 right there. So what's the y value going to be? 0. So that's my answer. So whenever the x value is 0, the y value ends up being my b. And in this case, my b is 0. So y equals 3x plus 0. Okay? If you're looking at this and you're like, oh, I don't know, watch it again. And I have several other videos that I do the same exact thing several times. Just go to the Chapter 6 playlist and find those big videos that you can watch and check it out there. I'm going to approach this the same exact way. I have to find my pattern. So again, I'm writing out an equation, which looks like that. I have to find my slope, which is the change in the y's over the change in the x's. So here's my x's. Add 2, add 2, add 2, add 2. Here's my y's. Now, if you're like, what's f of x? F of x is y. We'll change it at the end because it says use appropriate letters. Okay? What happens over here? Add 3, add 3, add 3, add 3. So my slope is the change in the y values over the change in the x values. My y values were 3, my x values were 2, so my slope is 3 over 2. Y equals 3 over 2x. Now, what's my b? My b is whatever the number is when x is 0. When x is 0, my number is 9. So my b is plus 9. Now the problem says use appropriate letters, which I haven't done yet. Normally my y is on the right side of the chart here. But in this case, it's not y, it's f of x. No big deal. Just change y into f of x. Okay? So that's the live version of Chapter 6. We'll do it live! That's that. If I have 2 other Chapter 6 playlists that would be much better to watch because it's not live and you don't hear my children misbehaving in the background. I highly suggest you watch that. Bye!